This is Calculus 2 class. This session, we're gonna study trigonometric substitution. So far, we learned substitution method, integration by parts, and trigonometry integral. Now, we're gonna work on trigonometric substitution. First, we have to identify when trigonometric substitution applies. Second, apply the substitution and simplify using trigonometric identity. Third one is back substitute to return to the original variables. Let's start trigonometric identity. Before you introduce trigonometric identity, let's think about two different indefinite integral. So I have two indefinite integral which looks very similar, but there is a difference. Left is they have x in front of square root n minus x squared. Right is just integral square root 1 minus x squared. So left integration, which method it works, guys? This one is u substitution works because you're gonna put the u gonna be 1 minus x squared, du gonna be negative 2x. But right side, integral square root 1 minus x squared dx, we cannot evaluate with any technique we learned so far. Now, we need new integral technique to evaluate this integration. Look at this form, square root a squared minus x squared. This form, we're gonna use trigonometric substitution method. So what are you gonna do? X gonna be a sine theta. We're gonna substitute. Dx gonna be a cosine theta d theta. Then we're gonna use Pythagorean identity. Cosine squared theta equal 1 minus sine squared theta. Let's give the one great example for this substitution. So integral square root 1 minus x squared over x squared case, any method we learn does not work for this indefinite integral. So we use trigonometric sub because that's 1 minus x squared there. So we use 1 minus x squared equal 1 square minus x squared. A should be 1. X gonna be a times sine theta. That's gonna be sine theta. Dx gonna be cosine theta d theta. Here is very important thing you have to make a good decision is find the right trigonometric substitution after the follow the each step. Now, let's simplify square root 1 minus x squared. So what are you going to do here? 1 minus x squared, you plug in the x equals sine theta. That's going to be 1 minus sine squared theta. 1 minus sine squared going to be cosine squared theta. What do you need? We need the square root 1 minus x squared. So square root both sides. That's gonna be square root cosine squared theta. It's gonna be cosine theta. Now, let's plug in back the original integration. Integral cosine theta in numerate. X gonna be sine theta. That's why sine squared theta. Dx gonna be cosine theta this theta. Now, let's simplify this one. Cosine, cosine square theta over sine square theta this theta. Use the identity. So we're gonna put together cosine theta over sine theta square. Guys, remember trigonometric identity? That's gonna be cotangent theta equal cosine theta over sine theta. This gonna be cotangent square d theta. We're gonna use the Pythagorean identity one more time. Cotangent scale theta gonna be cosecant theta minus 1. This one gonna be integral cosecant scale theta minus 1. antiderivative cosecant theta gonna be negative cotangent theta minus antiderivative one is theta plus c. We are not done yet, guys. Original function is function of x. This is a function of theta. We have plugging back. How gonna do it? Let's go to that one. So we find integral square root 1 minus x squared over x squared dx equal negative cotangent theta minus theta plus c. Cotangent theta should be changed into the x variable. Let's start cotangent theta. What is x from the beginning? X is sine theta. So sine theta is opposite of hypotenuse. So we draw the right triangle. Where should be x? X is gonna be opposite over hypotenuse. X is right there. 1 is hypotenuse. Now we need cotangent theta. So before we're looking for a cotangent theta, we have to find adjacent. Adjacent gonna be square root 1 minus x squared. Now, what is cotangent theta? You can use one of tangent theta or definition of cotangent theta gonna be adjacent over opposite. Now, you find cotangent theta equal square root 1 minus x squared minus x. Now you find that one, right? So negative cotangent theta equal minus square root 1 minus x squared over x. What do you have find? You have find the theta. What is the theta? So that's you're gonna find it, right? So x equals sine theta. We need to find the angle. So we're gonna use inverse trigonometric function. Theta gonna be arctangent x. So we find theta equal arctangent x. So we have minus arctangent x plus c, guys, okay? So this first example is we use x equal a sine theta, okay? Square root a square minus x square form, you're gonna use x equal a sine theta trigonometric substitution. Second part is square root x square plus a square form. We're gonna use x equal a tangent theta dx gonna be a secant square theta d theta. We using trigonometric identity tangent square theta plus 1 equals secant square theta. Okay? Let's have example right here, guys. Integral 1 over x squared plus 4dx. X gonna be x squared plus 4 right there. That's x squared plus a squared form. So x squared 4 equal x squared plus 2 squared. A gonna be 2. So x equal 2 tangent theta. Dx gonna be 2 secant here theta d theta. Now, we're gonna simply plug in back the x equal 2 tangent theta. So x squared plus 4, meaning is 2 tangent theta squared. 2 squared is 4. Tangent squared plus 4. So we have 4 tangent squared theta plus 4. What is common factor? Your common factor is 4. So that's going to be tangent squared theta plus 1. We using tangent scale theta plus 1 is secant scale theta. So you have 4 secant scale theta. Now plugging back everything right there. X squared plus 4 is 4 secant scale theta. Dx gonna be 2 secant scale theta d theta. So what do you have now? Integral 1 over 4 secant scale theta equal 2 secant scale theta. What is cancel out? Secant scale theta cancel out. 2 divided by 4, that's 1.5 d theta. So 1.5 is take it out in front of integration. So 1.5 integral 1 d theta. What is antiderivative? 1 is theta. You have 1/2 theta plus c. Now you have find the theta, right? All the way up, x equal 2 tangent theta. We have find the theta. First, isolate tangent. That's gonna be x over 2 equal tangent theta. Now we have find this theta, which meaning is we're gonna take inverse trigonometric. Theta gonna be arctangent x over 2. Final answer gonna be 1/2 arctangent x over 2 c. Let's do the last trigonometric substitution. Look at this one. This one is a square root x square minus a square. That case, we're gonna use trigonosub x equal a secant theta, dx gonna be a secant theta tangent theta d theta, and then we're gonna use tangent scale theta equals secant scale theta minus 1. So let's have this example, guys, okay? We're gonna do integral 1 over 2 square root x square minus 1 over x dx. You see x square minus 1 there. X square minus 1 is x square minus 1 square. Now, a equal 1, x equals secant theta, dx equals secant theta, tangent theta, d theta. Let's plug in into the integrand. X squared minus 1 is secant squared theta minus 1. That's gonna be tangent squared theta. So square root x squared minus 1 equals square root tangent squared theta. That's gonna be tangent theta. Now, we have plugging back into this integration. Before that, we have changed boundary. X equal 1, secant theta equal 1. Secant theta is 1 of cosine theta. Cosine theta gonna be 1 of secant theta. So secant theta 1 is meaning is cosine theta is 1, theta gonna be 0. Okay, upper limit x equal 2, which meaning is secant theta is 2, which means cosine theta 1/2, theta gonna be pi over 3. Now, you just substitute everything right there. So this definite integral gonna be integral 0 and pi over 2. Square root x square minus 1 is tangent theta. X gonna be secant theta. Dx gonna be secant theta, tangent theta, d theta. Secant theta is cancelled out. Now you have integral 0 and pi over 3, tangent square theta, d theta. Guys, remember that? Tangent power is even right there. So we're gonna use Pythagorean identity. That's gonna be integral pi over 3 of 0 to pi over 3 secant square theta minus d theta. Antiderivative secant square theta gonna be tangent theta. Antiderivative 1 is theta. Where to where? 0 to pi over 3. When you plug in the pi over 3, tangent pi over 3 minus pi over 3, 0 there. That's gonna be tangent 0 minus 0. Tangent pi over 3 gonna be square root 3. Tangent 0 gonna be 0. So we got the answer. Square root 3 minus pi over 3. Let's have a little challenging problem for the trigonometric substitution. Guys, look at this integration. Indefinite integral, look at the denominator. We did x squared plus a squared form or a squared minus x squared form or x squared minus a squared form. This one is looks different. X squared plus 2x plus 2. So what you have to first, you have to make complete square of something square plus something square or something square minus something square, something like that. So we have to make complete square right here. So x squared plus 2x plus 2, when you make complete square, we really focus degree 1 coefficient. That's gonna focus on 2. Half of 2 gonna be 1 and square. That's you add 1 square there. Add 1 square, you have to subtract 1 square right there. So you simplify this one. Parenthesis is gonna be x plus 1 square. 2 minus 1 square gonna be 1. That's you made complete square. Now, this one is, can you see that this one is x square a square form? So in this case, x gonna be x plus 1, a gonna be 1. So you have x equal a tangent theta because this is x square plus a square form. A gonna be 1. So what is gonna be substitute here? X plus 1 is tangent theta because A equal 1, dx gonna be secant theta d theta. Now go back to the integration right there, guys. X square plus 2x plus 2 gonna be x plus 1 square plus 1. We did a complete square. That's gonna be tangent theta square plus 1. Tangent square theta plus 1 is secant square theta. So now let's go back to original integration. Integral 1 over secant square theta times dx gonna be secant square theta d theta cancel out. You have just 1 d theta. Antiderivative is 1 gonna be theta plus c. X plus 1 is tangent theta. We need looking for a theta. Theta gonna be arctangent x plus 1. Now plugging back into the original integration, that's gonna be arctangent x plus 1c. This is a little challenging, but you have to do complete square first, then you looking for the form, trigonometric substitution form. You have used substitution method to evaluate the indefinite integral. What do you learn from this session? We learned trigonometric substitution method, but first you recognize the integral form suited for trig substitution. It's a little tricky, but when you see integrand x squared plus a squared form, x squared minus a squared form, a squared minus x squared form, then you might consider trigonometric substitution. Second is use trig identity to simplify and integrate in theta. Then don't forget it. Last part is return to the x for the final answer.